I'm Becca Jones-Albertus. I am the Program Manager for Photovoltaics R&D at the SunShot Initiative. And this means that I oversee all of our funding for photovoltaics research and development at the national laboratories and academia and industry. We focus on reducing the cost of solar electricity through improving reliability, improving performance, and reducing manufacturing costs. The SunShot Initiative is a national effort launched in 2011 by the Energy Department to make the cost of solar electricity competitive with conventional electricity sources without subsidies. So we have a target of 6 cents a kilowatt hour for the cost of solar electricity by 2020. If we reach this target, our models have shown that it's likely that solar could produce about 14% of the US electricity by 2030, if we reach these cost targets by 2020. So we fund, at the Solar Energy Technologies Office, we fund research and development and other funding grants to further the goals of the SunShot Initiative. Our budget this year was $233 million. We take a portfolio approach to funding, so we can't predict the future. We don't try to predict winners. What we try to do is fund a portfolio of approaches that together hopefully have solutions in them that get us to the SunShot goals and beyond. So we do have large numbers of programs in the photovoltaics program that I lead, which is about 1/5 of the total SunShot Initiative. We have about 70 different projects. So we do have hundreds of projects going at one time, but this allows us to address the many different problems that we need to lower the cost of solar electricity and to fund many different solutions and pathways in all of those. One way of looking at technology innovation is looking at solar cell efficiency records. And over the past about 40 years that we've been keeping track of solar cell efficiency records, over half of the world records for different technologies have been funded by the Department of Energy. Well, the field is making fantastic progress. We are more than 2/3 of the way to the SunShot goals, and this is a result both of the wonderful programs that we've funded as well as all of the other things going on and all the other progress in the industry has been making. But when the SunShot Initiative was launched, solar was about $4 a watt in the installed system price. And now we're down to almost $1.60 a watt. The target in installed system price is $1 a watt. The last bit of work is often the hardest, but there's been tremendous change in the last 5 years in the industry. Innovation is critical in many different ways to get us to these targets of solar that's cost competitive. And actually beyond our SunShot Initiative targets in 2020, as we look to 2030, we need to make solar even lower cost so that as we get large fractions of solar on the grid, we're able to integrate it with storage and other things that will have their own set of costs. So we need to bring the costs down dramatically from where they are today, both by 2020 and 2030. And there's opportunities for this community in making the cost of photovoltaic systems and concentrating solar power systems cheaper through improved light collection and cheaper light collection with high performance, through improvements in reliability, better ways of getting more power out of the same system, which again can involve optical tricks, can involve new designs, and doing all of this with an eye towards how we can reduce cost. The goal is for solar to be so cheap that there's no reason not to choose it. And the initial goal of making solar cost competitive without subsidies, without conventional electricity choices, with conventional electricity sources, would make solar an easy choice for times when the sun is shining. And our long-term goals, because solar is intermittent, is to make solar plus storage or demand response or whatever we need to integrate it into the grid lower cost or equal in cost to conventional electricity sources. And hopefully everyone will be in favor of installing solar energy if that's the case.